Now we come to intrinsic special variables and intrinsic functions. They each begin with a dollar sign. The special variables tell us something about what's going on in the system or about some other status. Many of them are quite specific to your system. Some of them are general across all systems. A dollar sign horolog gives you a timestamp. It's in days and seconds. We'll get to a dollar sign IO tells you what the current IO unit is. Dollar sign test, of course, it tells you whether the last operation succeeded or failed after certain operations, not all. Dollar sign X and Y tell you where you are on your page in terms of how far across the page and how far down the page. It's probably not used too much anymore, but it can be handy if you're trying to limit the amount of text per line. Dollar sign X is useful for that. Intrinsic functions that you can see listed here are the ones that are built in. They're principally string manipulation functions, although some are not. We'll go through each one of them. A couple we will not cover, the dollar sign Z functions, for example, and the Z intrinsic variables. They're implemented by the author of your system. They mean different things. They're implemented or defined. But the others should be pretty standard. Some of them are really quite trivial, so we won't spend too much time on them. The function $ASCII returns the ASCII equivalent of a character. So if you pass down to $A or ASCII, it's abbreviated just with an A. The capital letters you see in the document indicate what the abbreviation is. $A, passing down a capital A will yield 65. Because in decimal, 65 is the equivalent of the letter A. If you pass down Boston, you'll get 66. You'll only get the first letter. If you pass down Boston, 2, you'll get the value of O, the second letter of Boston, which would yield 98. In ASCII, the lowercase letters are higher value than the uppercase letters. That's not the same in IBCDIC, by the way. Extended Binary Coded Decimal Interchange Code, which is used on IBM mainframes. $char is kind of the reverse of that. If you give it a number, it yields the character. So if you give it 65, it comes back with the letter A. If you give it 65, 66, 67, you get capital ABC back. If you give it an invalid code, it's ignored. So 65, 1, 66. Well, 1 is not a printable character, so you're not going to get anything back. You'll just get AB. $data we've been over. It's the function that tells you whether or not a variable exists, whether it has descendants, that sort of thing. We've been through that a little earlier. $extract is used to extract a substring from a variable. It's got two formats, as you see. $extract, if I give it the string ABC, that's the source string. That, of course, can be an expression or a variable, anything like that. $extract of ABC, 2 yields the second character, which is B. $extract of ABCDEF, 3, 5, will start at position 3, which is a C, and go through and including position 5. Which is E. Notice that Mumps begins counting at 1, not 0. So the first character in a string is normally referred to as position 1. Find looks for a substring in another string. So go down to the examples is the easiest way. If the string is ABC and the thing we're looking for is B, it's going to yield 3. Why 3? B is in the second position. It yields you the address of the byte immediately following the string it found, which is useful for substitution and so forth. It's generally after it that you want. But anyway, it yields the byte, the address immediately following the thing it found. You can use longer strings. It could look for a word inside of a longer string. If you pass it a third argument, that's the position at which it starts looking. So if I have ABC, ABC, and I'm looking for the letter A, and I say 3, it'll begin looking in position 3, and it finds it in position 4, so it returns 5. Again, it returns 1 higher than where it where it actually is. The $F number is used to format. It's a more clever formatting technique than was originally in the language. Originally, in the language you used $justify. And the format codes get a bit complicated, and you would probably want to look them up in your manual. But it is used to format numbers with commas and decimal points and so forth. And it's based on your local currency flags as to how it does it, whether you're going to get how it's going to produce them. For example, comma and decimal point are not the same in European. They reverse them basically. $get returns the current value of a variable or a default value. So if I say kill x, in other words, I don't have x in my system. I've just deleted any instance of the variable x, and I say get x, comma, question mark. It can't find x, so it's going to return a question mark. If x is equal to 123 and I say get x, it will yield 123 because it did, in fact, find it. $justify has been in the language since the beginning. It was the original formatting for output, formatting of numeric output. What it does is it places the first argument in a string the length of the second argument right justified. So if we have, if the first argument is 39 or any expression or something, it could be characters, it does not have to be numbers. It will right justify 39 in a field of width 3. So what you get is blank 39. The 39 is right justified. You can see a second example there, the word test in a field of width 7, and you've got several blanks. Some of the blanks were eliminated here in the PDF. The word processor takes them out, but it would be a field of width 7, so there would be 3 blanks in front of the word test in the actual string. The third argument, if given, is the number of positions to the right of a decimal point. Now, this does imply you're giving a numeric argument. So if I have 39 as the argument, and I want it in a field of width 4, comma 1, it means I want 1 position to the right of the decimal point. And rounding will occur if there are more than the number of positions to the right than you give. $length returns the length of a string most commonly. You pass it down, for example, if x is equal to the string 124 space x space 5678 space x space 999. Okay, $length of x will yield 18. I assume that is 18. I'm not going to count it now. If I say if I give it a second argument, it'll tell me the number of parts in the string that are delimited by x. Now we see in the original string there's 2 x's, but there are 3 parts. There's the first numeric part, the second numeric part, and the third numeric part. So if I say pass it the string in variable x and I ask for the constant x, it'll come back and saying 3, meaning that the string is divided into 3 parts by the letter x. $name function returns you a string with all or part of the array indices filled in. So if I have the variable x equal to 10, the variable y equal to 20, and z equal to 30, $name, notice I've used the NA, just the abbreviation to keep the line short, $NA on ABC, x, y, z will yield you a string which will look like this: ABC, paren, quote 10, close quote, comma, quote 20 in quotes, comma, 30 in quotes, close, where it has substituted in the values of x, y, and z, or any expression that was in the place of x, y, and z. If I give a third argument, it gives that many indices. So if I have ABC, x, y, z, and I ask for 1, I'll get ABC with just the first index filled in with quoted 10. It does quote them even if they're numbers, which is perfectly legal. Numbers can be quoted. They don't have to be, but strings do have to be, and this could, of course, result in a string, in which case it would have to have quotes. If I give 2, it will give me the first 2 indices filled in. It's used in some indirection operations. The array ABC does not need to exist. Okay, it's not necessarily a real array. You're just generating something. $order, we've already looked at this in considerable detail. It you provide it with an array reference and possibly a second argument. What it'll do is it will find you the next ascendant value of the last index in the reference that you gave. So if you gave ABC parenthesis x comma y as your reference, it will return the next ascending value of y if there is one, or an empty string if there isn't. And if you put a -1 in as the second argument, it'll give you the next descendant value of the array of the last index, or an empty string if in fact there are none. And there are several examples here, but we have been through them. A $piece is kind of interesting. It's somewhat similar to the second usage of $length. It returns you a substring based on a delimiter. And the easiest way is look at the examples. If I have a string a.bx.y, and my delimiter I'm searching for is dot, and I'm looking for the second string delimited by dot, it'll return bx. So you see, if dot or period is the delimiter, the second part of the string delimited by dots is bx. If I say 1, I'll get a. If I said 3, I would get y. If I give a third argument, I'll get the strings between those. So if I say 2, 3, which means second part to the third part inclusive, I'll get bx.y. The dot will be returned in that case. It's very, very handy. It can be used on the left-hand side of an equal sign. Not many functions can. This is one that can. So if I have a string abc.def.ghi, okay, and I want to replace the second part of that string, in other words, that would be the def, I would say $piece x, comma, quote, dot, quote, comma, 2 equals XXX. And what it would do, it would put the XXX in where the def is. The XXX need not be the same length. It can be shorter, it can be longer. But it will substitute that part with a different value. QLength returns the number of subscripts in a variable name. So if I have the variables I is equal to 1, j is equal to 2, k is equal to 3, and b sub 1 is equal to 99, that's the value of the array element, and I say write QLength of up arrow a, I comma j comma k, it'll write out 3 because there are 3 subscripts in the array reference. If I say write out QLength of up arrow a, b sub 1 comma 2, it's going to write out 2 because there are 2 indices actually being given. If I say write out QLength of up arrow a, it comes back 0 because there are none being given. Q subscript returns you a portion of an evaluated array reference. So if we have the variables I, j, and k and equal to 1, 2, and 3 respectively, and the variable m equal to the string k, which we'll see we can use in direction, $Q subscript of up arrow a, I comma j comma k comma 0 will get me the name of the global array. It'll return up arrow a is the evaluation. Whereas if I have the same expression and the second argument is 1, I'll get the value of the first index, which happens to also be 1. If I have a 2, I'll get the value of the second index. And if I have a 3, I'll get the value of the third index after it's been evaluated, since it's at m. At m, of course, m contains k, and that would evaluate to a 3 because the value of k is 3. $query is used to give you the next ascending value of an array reference in the array space. So if I have an array, array called A, and it has indices 1, 2, 3, it also has indices 1, 2, 4, and 1, 2, 5, and if I set a variable x equal to the string A, and I do a query on at x, notice it has to be indirect, I will get back a sub 1, 2, 3 as a string. That's what I'm getting back. At x evaluates to a, which is just the name of the array. This is a local array, but obviously this works with global arrays too. So if you just give it the name of the array, it'll give you the first thing in the space. This assumes there's no other earlier elements of the array A than 1, 2, 3. And again, if you pass it the result from the first call, it'll give you 1, 2, 4, and so on. The thing is that if there was another element, if there was an a sub 1, 2, 4, 1, a 4-level element, it would be alphabetically following a sub 1, 2, 4. So when I called query, passing it a sub 1, 2, 4, the next thing I would get back would be a sub 1, 2, 4, 1, because that's alphabetically next in the array space. So in that way, it's different than order. It allows you to scan an array, usually a global array, continuously. We'll give some examples when we do the examples portion of this tutorial. $random returns you a random number between 0 and 1 less than the value you give it. So if I give it random of 10, I'll get a random number between 0 and 9. Again, this may vary from some systems because some systems have upper limits on the value you can use for a random number, but in mine there isn't. $reverse, you give it a string, it gives you the reverse of the string. So if I pass a string ABC, I'll get back the string CBA. $select is kind of like an if statement in sorts. What it does is it starts evaluating expressions. And the first expression that turns out to be true, it will return the value following the colon. So if x is equal to 10, if that's the value I've set it to, and I have the expression in the select x equals 9, well, that's not true, so it's not going to return a. The next expression is x equal to 10. It is true, so it will return a b. The remainders will not be evaluated. It was a way of doing an if statement, basically, where you had to test a number of things. It's not very efficient. $text returns you program code. You're going to remember this is an interpreter, and all of the code is supposedly there in its source code form. In reality, most systems compress it, and they have to decompress it in order to make this work. But anyway, if we have a program with the label L1, set A equal, and with set A equal to 10, set B equal to, and so forth and so on, if I were to say $text of L1, that would yield me the line containing L1. L1 space set space A equals 10 would be the result of that $text. If I said L1 plus 1, it would give me the next line. If I were to say $text of 4, assuming this is the entire length of the program, it would give me the fourth line, which is the line of comment. So in other words, if you give just a single number, it's an absolute number relative to the start of the program. This is used in some Mumps programs to store data. They will have comments, sometimes at the end of the program or at the someplace in the program, which contain data, and they'll grab the data by using $text. It's also used to modify code and execute code with different values. It can be quite unsafe, as you can guess. $translate is used to modify strings. If in the 2-argument form, it will, you see in the first example there, if the string is, the value of x is arma virumque cano, that's the first line from the Aeneid. If that's the value of your string, and if in the example translate $tr, I'm using the abbreviation again, x comma a, it will find all the instances of a and it will remove them. So the resulting string will be rm space virumque space cno. It did not substitute, it found them, but it found nothing to substitute. These can be longer than just a single character. This can be a string. If it finds any one of those letters, it would remove them in the source string. The other is to actually replace elements of the source string. So if, again, I have x, presumably the original x, not the one I just modified, the value of the string coming back is the modification. It does not actually alter x. And I said second argument is a and the third argument is capital A, it would find all the cases of lowercase a and replace them with uppercase a. Now, if this was a string ABC, there would have to be, well, there wouldn't have to be, but there would be a string capital A, capital B, capital C, and it would correspond. The first letter would be substituted by the first letter in the third argument. The second letter would be substituted by the second letter in the third argument, and so forth. $view is implementation defined. It was used. It normally used to be for debugging. You can look at certain system events and so forth. $Z is also implementation defined. Vendors can make their own functions, and they all begin with the letter Z.